Hi class, let's take a look at example 5. And in example 5, they're asking for a specific type of test for us to determine if the series is going to converge or diverge. And here's what we have. So for this test, we simply let f of x be, in this case, x over e to the x. And well, we have to do a couple of checks. The first portion is that it is continuous. So in this case, f of x is continuous from, well, technically on 1 to positive infinity, and in this case we're going to include that. And then the second portion is to see if it's decreasing. So a basic sketch of the graph. So let me just graph f of x, which is equal to x over the values of e to the x. And let me just get a couple of values. So this is y is equal to x, e to the x, and then x and y's. And let me just start at 0. So notice that it is defined at 0 because you're gonna get y is equal to 0 over e to the 0, or e to the 0 is 1. So this will be 0, 0. So this is just to confirm that it's actually decreasing. So we do have a point at 0, 0. And then let me plug in technically 1. So y is equal to 1 over e to the first power. And I'm getting that this is approximately 0.36. So 0.36. So you're going to have a coordinate point at 1, 0.36. So this is 1, that's 1. So about there. Let's select 2. So y is equal to, in this case, 2 over e to the second. And I'm getting that this is approximately 0.27. So 2, 0.27 about here gives us the intuition that this function is actually decreasing. Okay, so let me just rewrite it as f of x is decreasing on technically 1 to the positive infinity. And just so that we get a perspective, this is what it looks like. This is your x over e to the x. You can actually see that it is defined at technically 0, and then from there it basically decreases towards infinity. So we can apply the integral test. If those two conditions are not satisfied, then we cannot actually apply it. Okay, so now that we checked that all the premises are good for the integral test, let's actually evaluate it. So the integral test here it's actually going to be equivalent to the following. So we're going to be evaluating the integral from 1 to infinity of technically f of x dx, which is going to be equivalent as the integral from 1 to infinity of technically x over e to the x dx, which is actually going to translate as the limit as t approaches infinity of the integral from 1 to t. And let me just rewrite the e to the x on the top. It'll be easier to evaluate. And this is going to be x e to the negative x technically dx. And now that we have it in this format, it'll be easier to do by tabular. So we're going to have x and then e to the negative x. So this will be 1, 0. So this will be negative e to the negative x and then e to the negative x. and then we're pairing these up with the plus minus. So this actual integral is actually giving us, and let me move this up to here. So we still have the actual limit. So we still have the limit as t approaches infinity of, well, actually no more integral. The resulting of this integration gave us the negative x e to the negative x, as I'm pairing these two, and then minus the e to the negative x, evaluated from 1 to technically t. And let me see if it'll be easier for us to factor. No, let me leave it there. Okay, so let me actually evaluate the limits. So in this case, this is going to be equivalent to the limit as t approaches infinity of negative t e to the negative t minus e to the negative t, that's going to be 1, minus technically negative 1 e to the negative 1 minus an e to the negative 1. So that's for the second portion, and let me simplify this as much as possible. So we're looking at the actual limit as t approaches infinity of negative t e to the negative t minus an e to the negative t. And well, the last portion is just going to give us a, well, I'm getting a plus a 2 e to the negative 1 as part of the evaluation. And that's because, well, technically these two would be negative 2. Negative 2 e to the negative 1 with the negative, it's going to give us a plus. Okay, at this point, let me actually evaluate those three, and let me get a new piece of paper. Okay, so let me just continue this problem on the next page. Sorry, I'm running out of space here. And at this point, I'm just going to continue here. So we're basically looking at the following. We end up with 3 limits, and let me separate them. So this is going to be equivalent to the actual limit as t approaches infinity of negative t e to the negative t, and then minus the limit as t approaches infinity of e to the negative t, and then plus the limit as t approaches infinity of 2 e to the negative 1. Okay, so the first one is an indeterminate form. So I'm just going to use L'Hopital's rule. So by L'Hopital's rule, we're going to actually have the following. And in this case, this specific limit is going to be the limit as t approaches infinity of technically, let me rewrite it as negative t over e to the negative t. And I'm just going to apply the primes, which is going to give us a limit as t approaches infinity of negative 1 over e to the negative t. And this specific one, because of the negative, it's going to actually come from the bottom, and it's going to it's going to go in this direction. So let me see. Yeah, it's actually coming from this direction. So whoops, it's getting in this direction. So this one, it's going to be 0 as the infinity. So this is going to be 0. Your second one, so this will be minus the actual limit as t approaches infinity of e to the negative t. If I'm just looking at the this portion, this one is actually going to come in this direction. With the negative, it's going to look exactly like the previous one. So this one's going to also be 0, or I'll just rewrite it as minus 0. And then the only portion that we're left is basically the limit as t approaches infinity of 2e to the negative 1. So this whole problem, we end up with 2e to the negative 1 or 2 over e as our final answer. And then let me actually take it to the next page. So we can actually conclude on this one that the integral from 1 to infinity of, and the problem was x over e to the x, dx is equal to 2 over e, which actually means that in this case the sequence, well, actually in this case the series from n is equal to 1 to infinity of n over e to the n actually converges. Now your conclusion is only that it converges, and that's because this integral existed and we ended up with a value. So that would be your main solution, that it actually converges.